Next topic. Again, we're talking about variables, and what I want to discuss is the concept of what we call comparison and identity operators. Now, what is a comparison and an identity operator? Well, a perfect example would be, let's say that I have a value here where A equals 1 and B equals 2. So these are the two variables that I'm going to be working with. Now, I may want to compare those. Now, you may remember back from, grade school mathematics, we could do any number of things. I could actually, in math, so in standard mathematics, I could come in here and ask, well, is A equal to B? But the problem that we run into here is that in Python, the equal sign is an assignment operator. So in this instance, if I were to do that in Python and say A equals B, what that's going to do is it's going to change the value, the data, saved in memory slot A to match B, and that's not going to be what I want because, like I said, it's an assignment operator. So in Python, equals, so if I want to make certain or see if something is actually equal to something else, the equal comparator is actually going to be two equal signs. So just a little nuance that we got to keep in mind. There's also principles called like not equal. Now, not equal is going to be, I just want to make sure that I always screw this up. It should be exclamation point equal. And obviously we have other values. So in here what we're doing is we're actually looking at comparisons between fields. So other things you may remember from grade school are greater than, less than, or some combination of greater than or equal to, or less than or equal to. These are all very common comparison operators that we will need to become familiar with. So if we dive into, again, the script, I'm in the variables.py file, we can see right here that we have each of these components. So if I come over and say A equals 1, B equals 3, and we take a look at what's going on here, if I come up and say A and B, we see individual values. If I say A equals B, what I just did is I changed the value of A to 3. So what I meant to say was, does A equal B? Now the value here is going to be a true or false operation. So it says true. Does A not equal B? That'll be a false operation. So again, this is comparisons, and what's happening here is that we're actually comparing two values to one another, or more values to one another. And comparisons are, again, usually pretty helpful for us when we start looking at implementing things like network programmability. So another thing that I could do is I could say, is A greater than B? No. Is A greater than or equal to B? Yes. If I change the value of A back to 1, obviously A is greater than or equal to B. False. If I change it to less than or equal to B, it's false. I'm sorry, it's true. So keeping in mind that we can also do comparisons with strings. Now remember, a string is denoted, so if I come over here and I say Terry, is Terry equal to Terry? Well, the answer is no. But then the question is Terry equal to Terry? True. Now here's what I want to talk about next. If I say A equals Terry, and I say B equals Terry, A and B. Now the question is A equal to B in this instance? And the answer to that question is yes. And remember, if I come over here and say ID of A, that's its memory space. If I say ID of B, that's its memory space. So what we're doing is we're actually comparing to see if these two things are actually identical as far as the value. So if I come over here and I say B equals, and I just change it to Terry with lowercase, and I say A and then B, and I do ID of A, it's going to be in one memory space, and if I do ID of B, it's going to be in a different memory space. Ergo, these two things should not be the same. So A equals B, false. A does not equal B, true. So again, we see these values. Now, there is a difference here when we start looking at the other comparison that I want to discuss. So if I wanted to see if two values are actually equal, what I want to do is I want to verify it with this double sign. So are they the same? Now, when I say the same, I mean, do they have the same meaning? Now, here's what I want to do. What I want to do is I'm going to say true equals, and I'll say 1. Notice that says it's true. Now, does false equal 0? Yes, it is. It does. A equals 1. So is A equal to true? True. So what we're looking here is that these values for true and false actually have numeric designators to them. So false is 0, true is 1. Now, the next comparison I want to make is going to be using this is. So in this scenario, I'm going to say A equals 1, and I'm going to say B equals true. Does A equal B? False. Now, why didn't it equal B? So let's say that I can come in here and say type A, it's an integer, and I say type B, and it's a string. Well, let's redo B. Let's say, can I just do B equals true with no strings, with no parentheses, single quotes, not parentheses. So if I say A is 1 and B is true, and I say type for A should be an integer, and if I say type for B, because I didn't use quotations, it should actually be a Boolean, which it is. So now if I say A equals B, the answer is true. However, true is not 1. 1 is not true because they occupy different memory spaces. If I say that I want to do ID for A, the value of 1 is stored in this memory space right here. If I do ID of B, it's stored in a completely different memory space. So if I want to check to see if values are actually stored in the same memory space, what I do is I use the is. So in this scenario, I would say A is, and then since this is a function, I have to put what I want to apply the function against in parentheses. So in here, I'm going to say B, and it's going to come back in false. Where A equals B, but A is not B because they're not identical. They have the same mathematical variable or the same mathematical value, but the important thing that we need to keep in mind here is this is a comparison. This is an arithmetic comparison. The is function actually looks at where data is stored in that memory lattice or that memory space that I described earlier. So it can get kind of complicated, not overly so, but keep in mind that we do also have the capability of being able to compare strings. So let's see, the next thing I want to do will be Booleans. We need to talk about Booleans because Booleans are a perfect way, again, of being able to do comparisons. So we have comparisons where we're looking at the combination. So as an example, the equals, the not equals, less than, greater than or equal to, less than or equal to, things along those lines. But when it comes to actual Boolean comparisons, I'm looking, again, for true or false outputs, but I may want to be a little bit more granular than just looking at things from a mathematical perspective. So until I see you guys in the next video, I'm Terry Benson, and I'd like to thank you for learning Python with me.